at this point have had a kind of delay in what I'm saying with the picture, so hopefully that actually works on this one. Fingers crossed. I think I fixed it, so if you noticed that in the other video, I apologize. Hopefully this one is resolved. So we're going to do 6.2. This is the last section that you have to do this week. It probably will be a little bit of a longer video. There's a lot of material in this section. 6.2, apply properties of rational exponents. Okay, so we have several properties that we need to get written down here, and so these are in your book. If you don't want to write them down, that's fine, but I'd like to have them handy as we're doing problems. So, properties of rational expressions. Okay, so we have let A and B be real numbers and let M and N be rational numbers. The following properties, okay, they had the same names as those listed in the previous section on page 330 that we had done with properties of exponents, so we're just doing it with the properties of rational exponents now, so just so you know. Alright, so the property, we have, first one is a to the m times a to the n is equal to a to the m times n, or sorry, m plus n. I knew I was going to say that incorrectly. M plus n. 2, we have a to the m, all raised to the n, is a to the m. This one is now times n. Okay. And the book gives examples of what this looks like, but I'm just trying to run through the properties for the sake of time in this video. So, the next one we have a, b, all raised to the n. So a times b, all raised to the n, is equal to a to the m, b to the m. 4, we have a to the minus m. Hopefully you remember that gives us 1 over a to the m, assuming that a is not equal to 0. 2 more. 5, a to the m over a to the n is equal to a to the m minus n. Okay, so remember to bring that up to the top, or to switch wherever it is, we have to subtract it. Okay, so that's why we subtracted the n there. And again, we're assuming that a is not equal to 0. And the last one, a over b, all raised to the m, is equal to a to the m over b to the m, assuming now that b is not equal to 0, okay, because we can't have that denominator equal to 0. So there's some properties. I'm going to go ahead and get all the properties written down here, and then we will go through and actually do a bunch of problems out of the section, because this is a pretty long section with a lot of problems. So you probably won't have quite as many to do. I'll probably give you like every other odd instead of every odd like normal. So then we have the properties of radicals now. Okay, so remember in 6.1 we did some stuff with radicals, okay, and writing them as a fraction, like a fractional exponent. So we're going to kind of look at that now. So we have the nth root of a times b, okay, and notice this is being multiplied, not added or subtracted, it's being multiplied, so that's equal to the nth root of a times the nth root of b, okay, and this one we call the product property of radicals. Okay, and then we have another one. We have the nth root of A over B is equal to the nth root of A over the nth root of B. And we're assuming here B is not equal to 0 still. So I think we've kind of used these in this class without actually having formally learned it. So you've probably seen this before, but this one is called the quotient property of radicals. Okay, so we now have all of our properties here, okay, we can just say 8 properties that we need for this section. And the book gives you a ton of examples, so I'm not going to go through any of those. They do a pretty good job of explaining what they're doing. So I'm just going to jump to some problems to try to make this video itself as short as possible. But if you have more questions, feel free to send me a message and ask, and I will do my best to help you out. Alright, so take these properties away. To keep them handy, okay, they're not something you necessarily have to memorize, but eventually you should just naturally know them and be able to use them. Okay, so in terms of the problems, we are going to start with something a little bit more basic. Let's see, start with 4. Okay, so 4, we have 6 raised to the 2/3, and all of that, oops, sorry, you can't see that, it's not helpful, all raised to the 1/2. Okay, so according to our properties that we have, if we have something in parentheses and it's being raised to something, then these exponents are being multiplied. So I could rewrite this as 6 to the 2/3 times 1/2. Okay, well, the 2's cancel, leaving me with 6 to the 1/3. Okay, and that's an acceptable way to leave your answer. You do not have to do what we did yesterday, writing it as the cube root of that. Okay. Or rather, what we were doing in 6.1. I don't know if it was yesterday for you or not. Let's see. Trying to get a variety here. 8. So with 8, we have 7 to the 3rd over 4 to the 3rd, all raised to the -1/3. Okay? So what I would recommend dealing with first is this negative. Okay, remember this negative causes everything inside to flip. So I would rewrite it as 4 to the 3rd over 7 to the 3rd, all raised to the 1/3. Okay, you don't necessarily have to do it that way, but that would be my recommendation. Now, according to property number 6 that we had, okay, I can now split this and say that this is 4 to the 3rd times 1/3 over 7 to the 3rd times 1/3. Well, this raised to the 3rd and then the 1/3, okay, those cancel each other, so I'm just left with 4 over 7 as my answer. I should have boxed this answer up here. Let's see here what we can do. Let's go with 12. 12 looks good. So we have, this one is a fraction, 64 to the 5/9 times 64 to the 2/9, all over 4 to the 3/4. Okay, and we're trying to simplify it down as far as possible. So, with this one, okay, I'm going to first deal with the stuff on top, and then I'll deal with the stuff on the bottom, and we'll work through this one. Okay, so this would be 64 raised to the, well, according to the property, okay, we add the exponent, so it would be 5 plus 2 all over 9 because it's a fraction. Okay, so it would be 7/9 all over 4 to the 3/4. Okay? Now, I have a couple options for how I can proceed here. Okay, I don't know what the 9th root of 64 is, and without a calculator, I don't want to raise 64 to the 7th. Now, 4 cubed is something I could do, okay? 4 cubed, 4 times 4 is 16, times 4 is, 64. That could be helpful, okay? So I can maybe rewrite this one down here as 64 to the 1/4. So 64 to the 7 over 9 over, remember, 4 cubed, okay? 4 times 4 is 16, times another 4 is 64 to the 1/4. And now if I wanted to deal with my exponents, I could do that, okay? So I want to move this one up to the top, so I'm going to subtract it, okay? So come down here, 64 to the 7 over 9 minus 1 over 4. Okay, well I need a common denominator here, so this would give me, okay, 9 and 4, the first thing they have in common, I believe, is 36. So we'll say 64, and then this is going to be 36 is going to be the denominator. So in order to get this one, I have to do 7 times 4 is 28, minus 1 times 9 is 9. So 28 minus 9, so this is going to be 64 raised to the, what is that, 19 over 36. And I can't really simplify that down per se, so I am fine with you leaving it there, okay? The book gives you the answer of 8 times 2 to the 1/6, okay? So basically they do some stuff with pulling some things out of it and whatever, but I would say if you get here, I'm very content with that. You've simplified it down as far as possible. I would not expect you to go any further than that. Okay? Now, and there's some things where the book will give you like a really big answer, okay, instead of just leaving it and as something like this, they may give you, you know, whatever the ginormous answer is, like for 14, for example, they have 14 being 13 to the 3/7 over 13 to the 5/7. So they subtract the exponent from the top. Yeah, they subtract the exponent from the top, I guess, even though it's going to give us a negative exponent. So I'm actually going to subtract it down. So 1 over 13 to the 5/7 minus 3/7, which is 1 over 13 to the 2/7. And essentially what ends up happening is that they take this and they rewrite it as the 7th root of 371,293 all over 13. And that just doesn't really make sense to me to do it that way. So just ignore this part, okay, get to here and leave it, okay? So as long as you're using the properties of exponents that you're given, then you are good to go. And these shouldn't be too bad for you. Just checking an answer here to verify that all of these are the same. Okay, and those answers do come out to be the exact same, but I would prefer you just to leave it here because to get all the way to here just requires a calculator pretty much. So just leave it here when you get here, okay? That's what I was verifying, that those of those did in fact come out to be the same thing, and they do. Okay, so that section we're done with. That's just simplifying the expressions, okay? Now we're going to be simplifying the expression using the properties of radicals. So these up here were the properties of rational exponents. Okay, down here now we're going to be doing properties of radicals. Okay, so these ones, now we're using the second little set of properties that we wrote down. So starting with something easy, 16 is the third root of 16 times the third root of 4. Okay, so these have the same root on them, so they're both a cube root. Okay, and they're being multiplied, so I can just throw this all together. Okay, so 16 times 4 we already said was 64. So this is going to be the cube root of 64. Okay, so now the way that we need to think about these to get them simplified down as far as possible is we need to think the cube root of, well, 64, okay, is 4 times 4 times 4, okay? So I can pull out a 4 because there are 3 of them in there, okay? So you just need to see that kind of differently than we talked about before, okay? So that's going to be equal to 4. Now maybe off the top of your head you just knew, hey, the cube root of 64 is 4. But I just wanted to show you how you could write it out and make sure that you could do that. Okay, because you could have thought about it doing a factor tree. You could have come over and done that 64 is 8 times 8, and 8 is 2 times 4, and then you have a whole bunch of 2's that you end up with. So I end up with 6 2's, so 2 times 2 times 2 times 2 times 2 times 2. Okay, and I can pull things out in groups of 3. Okay, so there were 3 of those, so I could pull out a 2. I could pull out another 2, telling me that my answer is 4. Okay, if that confuses you, ignore it. I just was showing you how we would know, because we are going to need this when we start having to pull things out in like groups of 7. Okay, so if this confuses you for right now, ignore it till we actually need it, and just think about what the cube root of things are. Okay? Let's see, with 18, we have the cube root of 3 times the fourth root of 3 all raised to the 12th. Okay, so I would rewrite these in terms of fractions. Okay, so this is 3 to the 1/3 times 3 to the 1/4, all raised to the 12th. So now I would multiply the 12 through both of those fractions in your exponents to give you 3 to the 12 over 3 is 3 to the 4th, times 3 to the 12 over 4 is 3 cubed. Okay, and then you end up with 3 to the 7th. Okay, because you just add them together. Leave your answer like this, okay, because you technically don't have a calculator. Okay, the book answer is 2,187. Okay, but I would rather you just leave your answer in an exponent because you're not going to have a calculator if we get to have a quiz on this. Okay. 222. So this is the fourth root of 8 times the fourth root of 16, all over the 8th root of 2 times the 8th root of 3. Okay, so with these ones, we got the same stuff going here. Okay, the fourth root, and they're being multiplied, so I can rewrite the top as the fourth root of 16 times 8. To do over to the side, I don't know that off the top of my head. So let's see, what is that? 46, I think. So is that 126? Does that sound right? I'm going to verify that before I do the whole problem wrong. Oh, nope, I was wrong. 128. That's right, that's 48. 128, that's why I had to verify. Okay, so if you need your calculator for some kind of math like that you just don't do off the top of your head, I mean, that's fine, but you won't actually have them when it comes to the test, okay? So, 4th root of 128 over the 8th root of 2 times 3 is 6. I would rewrite these as fractions because I think it makes it easier. So that gives you 128 to the 1/4 over 6 to the 1/8. And as far as what you could do here, I would say go ahead and just leave your answer right here. Okay, I would not worry about trying to convert things over and whatever because we don't have the same number here and we have different fractions, so just leave your answer right here. Alright, so the next thing is to write the expression in simplest form. Okay, so stuff like 24. Okay, it's the square root of 72. Okay, so this is where I said that factor tree might come in handy. Okay, so the way this works is you make a tree. Okay, you should have done this before. 72 factors into 8 and 9. Okay, 8 factors into 4 and 2. 9 factors into 3 and 3. And then lastly, this 4 factors into 2 and 2. Okay, so the way I need to do this is I need to come over here and I need to rewrite this as the square root of 2 times 2 times 2 times 3 times 3. Okay, I hope you've seen this before, but I'm not sure that you have, so I want to go over it. Okay, so I copy down all the smallest factors here. Okay, now I pull things out in groups of 2 because this is a square root. So I can pull out a set of 2's and I can pull out a set of 3's. However, I don't pull out 4 and I don't pull out 9. Okay, I pull out a 2 and I pull out a 3 because there's 2 of them and it's a square root. Okay, so outside I get 2 times 3 times the square root of what's left is 2. Okay, so this ends up being 6 root 2 for the answer to that one. Ooh, look, it's about to fall. Okay. Now, let's look at another one and what this looks like for that. Okay? 26. So we have the cube root of 108 times the cube root of 4. Okay? Honestly, it's irrelevant what 108 times 4 is because I'm getting ready to factor it out anyways. So I'm just going to write the factor bars for 108 and 4. Okay, well I know 4 is 2 times 2, so that's easy. Now 108 is 9 times 12. Okay, so 9 times 12. Okay, 12 is 3 times 4, and 4 is 2 times 2. And 9 is 3 times 3. Okay, so the things I'm dealing with, I have a 3, a 3, a 3, a 2, a 2, a 2, and a 2. Okay, and remember I'm dealing with the cube root, so I'm factoring things out in groups of 3. So I'm going to write the cube root of, and I'm going to write all these things in here. So 3 times 3 times 3 times, I have 4 2's, so I'm 2 times 2 times 2 times 2. And now I'm pulling things out in groups of 3. So I have a group of 3 3's, and I have a group of 3 2's, and I'm going to have a 2 left over. Okay, so the way I write that then is 3 times 2 times the cube root of 2, or 6 the cube root of 2. Okay? Let's see. Let's do one more. Do 30, because this one is a fraction. So a 30 is the 6th root of 81 over 4. Okay, so I'm going to split this and do this kind of as top and bottom, and we're going to see here what happens with that. Okay, so let's just see what happens here. So I have the 6th root of 81 over the 6th root of 4. 81 doesn't divide by 4 evenly, so that's why we can't do anything with that. So let's just see. 81 is 9 times 9. 9 is 3 times 3. So I just end up with 4 3s. So immediately looking here, I can't do anything with that as it appears. Okay? But maybe I can look at how I can rewrite the top and bottom in a different way. Okay, I know that 81 is the same thing as 3 to the 4th. Okay, I can see that here. 81 is the same thing as 3 to the 4th. So maybe I could rewrite that as 3 to the, I'm going to rewrite the top as 3 to the 4, I'm still taking a cube, or the 6th root of it, and to the 4 over 6. Over 4, maybe I can think about that as 2 squared. So maybe I can think about that as 2 to the 2 over 6. Okay, but both of those are fractions that can be reduced. So that would be 3 to the 2/3 over 2 to the 1/3. So I have that reduced down pretty far. So I could probably just stop there if I wanted to. I could go up and I could make a common denominator and do some stuff with that, but the bases aren't the same, so I would say get here and call it a day. Okay, that's as simplified down as you can really go with it at this point. Okay, so if you get something simple like that, you are good to go. Okay, or if you wanted to go kind of one more step, since both things are the cube root, I could take the cube root of 3 squared, which is 9 over 2. If you wanted to do it that way, that would work as well. Okay? Let's see. This section has got a lot of stuff in it. So the next thing, combining radicals, simplifying the expression. So we have 32 is 2 times the 6th root of 3 plus 7 times the 6th root of 3. Now you're probably about to tell me, if you were sitting in my classroom, that we couldn't do anything here because based on what I said, you have to be multiplying to do anything, which is true. However, I can think of these as like terms. This and this match here. So the 6th root of 3 is in both pieces. So I can add what's outside of them without adding what's inside. Okay, so my answer for one like this would be 9 times the 6th root of 3. Okay? Now, let's see. Let's look at 36 here and see what we can do with this one, because this one's a little different. So 6 times the cube root of 5 plus 4 times the cube root of 625. Alright, well, 625 is a pretty big number. Obviously those don't match, so at initially looking at it, my thought would be that I can't do anything with it, right? So I need to figure out how I can divide it up. So We know 5 times 5 is 25. So let's just see if we can divide 625 up into anything. Okay, I know that, let's see. I know I could pull a 5 out, and just using my calculator to do some of these quick maths, okay, you're welcome to do that. 625, take out a 5, leaves me with 125. 125, I could take out a 25 and be left with 5, and then 25 is 5 and 5. That seems like this could be helpful here, because I could rewrite this. Okay, I have 4 5s here. So I have 6 times the cube root of 5 plus 4 times the cube root of 5 times 5 times 5 times 5. I'm taking the cube root, so I could pull out a group of 5s. Okay, so I could pull out this group here, which would be 4 times 5. So 6 cube root of 5 plus 4 times 5 is 20, and the cube root of 5. Now I can add it up because I have like terms, so I get 26 times the cube root of 5. Okay, so if something doesn't look the same, see if you can factor it out now that we've done a little bit with this, and see if you can pull something out to make it work. Okay, and again, if you get stuck on anything, you can send me a message and I will do my best to help you. Okay, as quickly as I possibly can. Okay, so that's that stuff. Let's go with, got a little bit more we got to get through in this stuff. Some of it I'm not overly worried about. Stuff like, well, this next little section of stuff is pretty easy. Okay, stuff like 44, y to the 4th, all raised to the 1/6, and it just wants it simplified, assuming all variables are positive. Okay, basically that just becomes, we multiply 4 times 1 over 6 because of the properties we have, so y to the 4 over 6, which simplified down as y to the 2/3. And that's all you have to do with that one. Let's see, 48 cube root of x to the 15th over y to the 6th. Okay, well this is x to the 15 over 3 all over y to the 6 over 3. Okay, just following property is why I'm running through these pretty quick. It's x to the 5th over y squared, and that's the answer for that one. See, 50 is something we have not talked about yet, so we'll do that one, take a minute with that one. So the cube root of x times the square root of x to the 5th all over the square root of 25x to the 16th. Okay? So, something that we had not done yet, okay, but that we can do, okay, is we can rewrite these to be able to combine them. So we haven't really done that yet. I guess we sort of did, and like without realizing it. But I'm going to rewrite these as fractions. So x to the 1/3 times x to the 5/2, okay, which means I'm adding their exponents, so I'm going to have to get a common denominator. On the bottom here, I'm going to go ahead and separate this stuff out, okay, in groups. So this is, obviously 25 is 5 times 5 times, now there's going to be 16 x's. I'm going to write 8 groups of x squared, okay, to make my life a little easier. Alright, let's check. 1, 2, 3, 4, 5, 6, 7, 8. Okay. hard to count and do that at the same time. That's why some of them look a little funky. Okay, so that means I can pull out 8 x's and I can pull out a 5. Okay, from the bottom. Okay, because they're in groups of 2. Taking the square root on the bottom. So my bottom, let me go ahead and rewrite, becomes 5x to the 8th. Okay, now on top. Okay, I have x to the 1/3 plus 5/2, so I need to multiply this one by 2 over 2. This is going to be x to the 2 over 6 plus, this one has to be multiplied by 3 over 3. That's going to be 15 over 6, okay, which gives me x to the 17 over 6 on top, all over 5x to the 8th. Now, the problem with the top is I need to think about this in terms of being able to pull stuff out, because that is not simplified down as far as possible. Okay, because right now I have the 6th root of x to the 17th. Okay, that means I would have 17 x's here. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, that's a lot of x's, and I have to pull them out in groups of 6. Okay? Nope, that's an 8, not a 2. So, I'm going to count them off in groups of 6 and see how many I can pull out. So, 1, 2, 3, 4, 5, 6. That's a group of 6. 1, 2, 3, 4, 5, 6. That's another group of 6. And I'm left with 1, 2, 3, 4, 5. Okay, so I can't pull any more out. So I can pull out 2 x's on the top, or x squared. So I get x squared times the 6th root of x to the 5th, all over 5x to the 8th. Okay, so that's what I'm left with there. Okay, this x squared and the x to the 8th, that becomes x to the 6th. So I have the 6th root of x to the 5th, all over 5x to the 6th. Now, okay, and that would be my final answer for that one. So I know that's a lot, having to pull out all those x's and stuff. Okay, this is about as hard as these problems get. So don't stress about them too much. Alright, so 2 more little things we need to do in this section, and then we'll be done. Okay, I know it seems like a lot. This probably would have been over 2 days in class, so if you need to take 2 days to kind of get through all this, please feel free to do that. So write the expression in simplest form, assume all variables are positive, so really not any different than what we were already doing. Okay, but we have, let's see, like 54. We have the cube root of 4x cubed y to the 5th times cube root of 12y squared. Alright, we have the same root being taken of them, so I can multiply everything that's inside. Okay, again, because I'm pulling stuff out, I don't even need to multiply 4 times 12. Like, yes, I know that's 48, but I don't really have to worry about that, okay? So the cube root of, I'm going to go ahead and write it that way since I said it, but cube root of 48 x cubed y to the 7th. Okay, remember we're adding exponents because we're being multiplied. So now, I need stuff in groups of 3. So 48, we already know is 12 and 4. We know that's 2 and 2, 4 and 3, 2 and 2. So I have a bunch of 2's, and I have 3 here that I can rewrite that. And I'm going to rewrite my variables individually and group them then. So the cube root of 2 times 2 times 2 times 2 times 3 times x times x times x times, now I have to do 7 y's, so 1, 2, 3, 4, 5, 6, oh, not going to have room to write the last one, 7. Got close. Kind of run into each other there. Now I'm going to group things in groups of 3 so I can see what I need to pull out. So I can pull out a group of 2's, I can pull out my x's, I can pull out a group of y's, another group of y's, and there's still this y left over down here, so don't forget about him. He kind of ran into stuff over there. Okay, so now this is, we can pull out a 2x, I'm pulling out 2y, so that's going to be y squared. So I'm pulling out 2xy squared times the cube root of, well, what's left over is 2 times 3, 6, and I had a y left over, so 6y. So this right here is my answer. 2xy squared times the cube root of 6y. And that whole section is pretty much just like that, so you just have to work through those. Actually, we'll do one last one of those and we'll just call it done, so we won't even do the one other thing that I was going to do. So square root of 20x cubed y squared over 9xz cubed. Okay. So, before I go too far here, okay, I want to cancel stuff out inside if I can. Okay, this x and this x cubed are going to become just x squared on top. And I'm going to go ahead now that I've said that, and I'm going to go ahead and split top and bottom. So the top is square root of 20. It's now x squared, y squared over the square root of 9z cubed. Okay, so I'm going to factor this stuff out. I don't even necessarily need to do a factor tree for 20 because 20 is 2 times 10 and 10 is 2 times 5. So it's going to be the square root of 2 times 2 times 5, x times x, y times y, all over. This is 3 times 3 times z times z times z. And I'm pulling stuff out in groups of 2. So I have 2 2's, 2 x's, 2 y's, 2 3's, 2 z's that I'm going to pull out top and bottom. Okay, so this becomes on the top 2xy times the square root of 5 over 3z square root of z. Now, if you remember from trig, we don't like roots on the bottom. So I have to multiply by the square root of z over the square root of z. Okay, so I'm going to go ahead and do that here. So this is 2xy times the square root of, now I'm multiplying two square roots, so what's inside of them can be together, 5z, sorry, that does not look like a z, over 3z squared. That would be my final answer. Okay, now your homework for this section is going to be (3 through 59), every other odd. Okay, if 51 happens to be in there, just cross it out, skip it, and go to the next problem that's in your group that you're supposed to do. Okay, do not do 51. Get rid of 51. Okay? Alright, I know this video was way longer than I planned on it being, okay, but this is material that we probably would have covered over 2 days, so don't stress about it if you don't get it right away. Okay, there is a lot more in that section we could have done, but I'm good with us just stopping there where we are.